Friends, you need a good imagination and a pile of junk. We, the ATL team of Haramain English School, present a hydraulic ramp pump as part of the Tinkering Marathon.
Myself, Shamil of Class 10, we are here to represent ATL at Haramain English School Dialect. I am
Hi, I am Akhtar of Class 10. We are a group of students who got the opportunity to work behind this project.
So we are going to introduce our innovation.
We focused on the topic water source management through this project.
Haramain is the one of good projects under this topic.
Then, why our innovation is different?
Conventional way of innovation constrained to control motor pumps using electrical or electronic energy.
We followed a method which doesn't need any external power.
And this method can be reproduced by any non-technical person, including an ordinary farmer.
What is hydraulic ramp pump? A hydraulic ramp pump is a cyclic water pump powered by hydro pump. It functions as a hydraulic transformer that takes in water at one hydraulic head at flow rate and outputs water at a higher hydraulic head and lower flow rate.
The principle behind it. Water hammer or hydraulic shock phenomenon can be understood as abrupt collision of fast-moving solid slug within the piping system with any obstruction. Thus, water hammer is defined as a sudden increase in pressure on account of hindrance to fluid motion or direction change.
Basic components. 1. Inlet drive pipe. 2. Free flow at waste valve. 3. Outlet the delivery pipe. 4. Waste valve. 5. Delivery check valve. 6. Pressure vessel. Description of parts. A hydraulic ramp has only two moving parts, a spring or weight-loaded waste valve, sometimes known as the clack valve, a delivery check valve, making it cheap to build, easy to maintain, and very reliable. In addition, there is a drive pipe supplying water from an elevated source. Delivery pipe taking a portion of the water that comes through the drive pipe to an elevation higher than the source.
The sequence of operation. Waste valve is open and the delivery valve is closed. The water in the drive pipe starts to flow under the force of gravity and picks up speed and kinetic energy until it forces the waste valve closed. The momentum of the water flow in the supply pipe against the now closed waste valve causes a water hammer that raises the pressure in the pump, opens the delivery valve, and forces some water to flow into the delivery pipe. Because this water is being forced uphill through the delivery pipe farther than it is falling downhill from the source, the flow slows. When the flow reverses, the delivery check valve closes. If all water flow has stopped, the loaded waste valve reopens against the now static head, which allows the process to begin again.
Advancements. A pressure vessel containing air cushions the hydraulic pressure shock when the waste valve closes. It also improves the pumping efficiency by allowing a more constant flow through the delivery pipe. Although in theory, the pump could work without it, the efficiency would drop drastically, and the pump would be subject to extraordinary stresses that would shorten its life considerably. One problem is that the pressurized air will gradually dissolve into the water until none remains. One solution to this problem is to have the air separated from the water by an elastic diaphragm, which is similar to an expansion tank. However, this solution can be problematic in developing countries where replacements are difficult to procure.
We ideated. We tinkered. Came up with a prototype. And we tested it. It facilitates water pumping without electricity.
Hence, it can be applied in ecotourism, farming, etc.
The design features. The optimum length of the drive pipe is 5 to 12 times the vertical distance between the source and the pump, or 500 to 1000 times the diameter of the delivery pipe, whichever is less. A typical efficiency is 60%, but up to 80% is possible. The drive pipe is ordinarily straight but can be curved or even wound in a spiral. The main requirement is that it be inelastic, strong and rigid, otherwise it would greatly diminish the efficiency.
Various developments and changes. Firstly, change the balloon into tube for more pressure generation. Secondly, increase the height of the water resource. Finally, it is always checked in the actual situation.
Now we are going to test a ramp pump in a real-life situation. As it can be applicable in green tourism and water irrigation sectors, we are implementing on a water stream in a hilly area near a school. The force of the water in the stream is utilized here to produce water hammer effect, and the water from the stream can be taken to a higher elevation. As you can see, we are not using any external power or fuel other than the initial push of the valve. Other highlights are: this device is completely non-polluting, eco-friendly, economical, easy maintenance. Layman can also understand the working. Future collaborations. We would like to work with Center for Water Resources Development and Management, Calicut. How will our innovation benefit? It will be a great contribution to the society, as this work can be useful where the requirements for the ramp pump meet. Most importantly, it will be counted under service rather than the business point of view. This can be utilized in green tourism. How can they help us? They can share their knowledge on this, help in troubleshooting and upgrading, support to analyze and evaluate the system, giving an authorized platform to showcase our work. With profound gratitude, we are signing off.